Test 1 2 3 1 2 3. Test 1 2 3 1 2 3. Test 1 2 3 1 2 3. Testing testing. Test 1 2 3 1 2 3. Testing testing. I am currently testing to see if the volume is working fine. I am currently testing to see if the volume is working fine. I am currently testing to see if the volume is working fine. Okay, I think this will do. One last test. Let's see. Music's not playing. Hello, hello. How is everyone today? Please tell me about your day. Testing 1 2 3. Please tell me about your day. Testing 1 2 3. And open in browser. Alright, we'll just open in browser. Keep that here for now. What the? Fucking garbage. And I test test test. Test test test. What? I think we need to bring this up a few notches. Investigate the math. Susan needs to make a box in the shape of a cube. Investigate the math. Susan needs to make a box in the shape of a cube. Investigate the math. Susan needs to make a box in the shape of a cube. Susan needs to make a box in the shape of a cube. Susan needs to make a box in the shape of a cube. Susan needs to make a box in the shape of a cube. Susan needs to make a box in the shape of a cube. So this feels so quiet. Susan needs to make a box in the shape of a cube. Refresh that and Susan needs to make a box in the shape of a cube. Susan needs to make a box in the shape of a cube. Susan needs to make a box in the shape of a cube. I think that's okay. Yeah, that'll do. That's okay. Yeah, that'll do. That's okay. stream, restream, and stream, restream, and stream, restream, stream, restream. Ooh, oh my gosh, what am I doing? Oh my gosh, what am I doing? What am I doing? Susan needs to bake. Susan needs to make a box in the shape of a cube. Susan needs to bake. Susan needs to make a box in the shape of a cube. Box in the shape of a cube. Susan needs to make a box in the shape of a cube. Box in the shape of a cube. Susan needs to make a box in the shape of a cube. Box in the shape of a cube. Needs to make a box in the shape of a cube. Box in the shape of a cube. Needs to make a box in the shape of a cube. Box in the shape of a cube. Is it done? Is it done? Is it done? All right. The inverse of a quadratic function. Determine the inverse of a quadratic function given different representations. You'll need graph paper. We don't need any of that. Investigate the math. Susan needs to make a box in the shape of a cube. She has 164 centimeters squared of cardboard to use. She wants to use all the material provided. Alright, what do we got here? Copy and complete this table. 1, 6. So each cube side is 1 times 6. 4 times 6 is 24. 3 by 3, 9 times 3. Alright, so this is just the area of each side of the cube. So each side length is 1, 1, 6 faces times 6, 6. 2 times 2 is 4, or 2 squared is 4. There's 6 faces. So we multiply that 4 and so on. We work all the way down here. 10 squared, 100. So the last one is 600. Our question is, she has 164 centimeters of cardboard to use. She wants to use all of the material provided. She wants to use all the material provided. So we're trying to what? Find x 6x squared equals 164 is what we're trying to solve, I guess. Or x is the length of the side of the cube, I think. Draw a graph of the surface area versus side length. What type of function is this? Draw a graph. A surface area versus side length. 1, 6. Draw a graph of surface area versus side length. Oh, like 1, 6, 2, 24, 3, whatever 3 squared times 6 is, and so on. Determine the equation that represents the cube's surface area as a function of its side length. So 6x squared uses function notation to state the domain and range. So x can equal any real number, or well, technically has to be greater than 0. And y also any real number greater than 0. How would you calculate calculate the inverse of this function to describe the side length of a cube? If you know its surface area, how would you calculate the inverse of this function to describe the side length of the cube if you know its surface area? So that would be 864. Let's see, we can do some quick maths here. We're gonna do 864 divided by 6 is 144, and we take the square root of that. Help, I'm dumb. Where is the square root symbol? 90% sure that's pi. Yep. Let me go back here. The square root. It's 100. Well, okay, like I know it's 12, but I need to figure out how do I square root something here. Isn't that square root? Oh, yeah. Didn't I press that last time? Weird. Okay, so anyways, our answer to this question is 12, and that's how we would calculate it. Make a table of values for the inverse of the surface area of the function. So the inverse is just swapping x and y. So it'd be 6y squared equals x. Draw a graph of the inverse. Compare the graphs of the inverse. So I think graphing tool. Let's see here. Sure, there's something we can find. Our graph is going to be 6x to the power of 2 is y, right? Our second one is going to be 6y to the power of 2 is x. And it was just rotated 90 degrees to the right. As we can see here. Is that better when it's full screen? Hell. I'm trying to look at OBS and fucking do this at the same time and see if it looks good. It is. I'm struggling. Help me. Okay, so that's what it looks like with that. And when I make it small, go here. Look at these. That versus that. I don't know. Looks good when small. I'll do it if someone else complains. Alright, back to here. Make a table of values for the inverse of the surface area function. Draw a graph of the inverse. Compare the graph of the inverse with the original graph. Is the inverse a function? Explain. No, it's not. Well, you can just tell that it fails the vertical line test. Just will cross right through there. Easy peasy. Okay, we got multiple values for x, so it fails. You can only have one value for every x coordinate, right? Draw a graph and compare. Whoops. We must have skipped this one last time. State domain and range of the inverse. So y can equal any real number and x needs to be greater than 0. But over here, y had to be greater than 0, which we fucked it up. I think when I said it last time, I fucked it up. But yeah, original function, y needs to be greater than 0, x can equal any real number. Inverse, it's literally inverted. Fucking brilliant. Write an equation that represents the cube's side length for Write an equation that represents the cube's side length for a given that's just it's just side length cubed, right? No, that doesn't make sense. Write an equation that represents the cube's side length for a given surface area. Write the equation that represents the cube's length for a given surface area. Write the equation that represents the cube's side length for a given area. Oh, so it's area divided by 6, square rooted. Square root of the area divided by 6, right? That's what we want. Use your equation from part H to determine the largest cube system. Yeah, so we already calculated that. That's going to be 12. Reflecting. How are the surface area function and inverse related? So the surface area function, I guess we call it the original, but its inverse is to find the coordinates while the original we have x, so we found y. This one though, use your equation from part A. Cube's side length. Anyways, we use the inverse to find the coordinates for x. The y for x and the x for y is for the original in their graph. So that inverse is just a 90-degree rotation in their domains and ranges. They just flipped in terms of their definition. How is any quadratic function related to its inverse? I guess it's just a rotation. And in their equations, I didn't write them out. Whatever. Given the graph f of x squared, graph the inverse relation. So again, we can probably just rotate that 90 degrees. See the answer right there, but whatever. state the domain and range of f of x equals x squared, and the inverse relational state the domain and range. So same as the previous one. Determine whether the inverse of f of x is x squared is also a function. Give a reason for your answer. Determine whether the inverse of f of x squared is also... No, it's not, because there are multiple y values for every x. So I'm guessing all inverse functions, all inverse equations are not functions. It's fair to say. So let's see how Paul solved this shit. To graph f of x squared, I took the coordinates. Yes, you're a genius. For example, 2, 4 became... Oh, okay. Never mind, actually is a genius. He just took the coordinates of the original and just swapped them. So over here, he had 2, 4. Therefore, inverse will be 4, 2. 4, 2. Okay. I had to do this because the input value becomes the output value for the inverse and vice versa. Okay, so that's what I was trying to say earlier. Okay, that's actually worded very nicely. I had to do this because the input value becomes the output value in the inverse. That's right. So inverse functions let us calculate the input values for the original function. The graph of the inverse is a reflection of the original function. Graph of the inverse is a reflection. Oh, it's a reflection, not a rotation. Oh, that's actually true, because technically it was a I guess. Yeah. I guess maybe it's both. Interesting. The domain of f of x squared is x equals any real number. And the range of f of x squared is y equals any real number. And y is greater or equal to 0. Therefore, the range of the domain of f of -1 is x equals 0. Okay, so yeah, again, they just swapped this. So definition for y becomes a definition for x, and x becomes y for the inverse. And the range is y equals 0. The domain of the inverse is the range of the original function. The range of the inverse is the domain of the original function. I knew this because, okay, the inverse of f of x equals x squared is not a function. Okay, so we were right about that. I knew this because the inverse fails the vertical line test. For each number in the domain except 0, there are 2 values in the range. Good stuff, good stuff. Easy peasy. Maybe we can probably speed through this a little quicker. Determining the equation of the inverse of a quadratic function. The equation of the inverse of a quadratic function. Okay, so I think this is where they're just going to tell us that the x and the y's just get swapped. Okay, so I think this is where they're just given the quadratic function, the x and the y's just get swapped. Okay, so I think this is where they're just given the quadratic function, the x and the y. Whoops. Let me mute that. Given the quadratic function f of x, x2, x plus 3 squared minus 4. Graph f of x and its inverse. Determine the equation of the inverse. Alright, I graph f of x by plotting the vertex -3 and -4. Why is he doing -3 and -4? That's an awkward number. Never mind, that's the vertex. Oh my god. You said that right there. Okay. Gotta read more carefully. The parabola opens up because the value of a positive. I found f of -2 equals -2 and f of -1 equals 4. The parabola opens up because the value of a is positive. Yes, I found f of -2 and f of -1 equals 4. -2 equals -2, f of -1 equals 4. To graph the inverse, I interchange the x and the y coordinates with the points on the original function. Yep. Makes sense, f of -1. Oh, interesting. See what he did here. It's not good enough that you just swap the x and the y. You actually have to... Wait, no, okay, you know what? Let's just read through this. First, I wrote the equation with y replacing f of x. Because y represents the output value in the function, to find the equation of the inverse, I interchange x and y in the original function. So we had f of x, 2x plus 3 squared minus 4. Y equals, okay. Just rewrote it, just using y instead of f of x. And then we swapped it. Now, solve for y. So now, basic algebra, plus, move the 4 to the other side, so x plus 4, divide by 2 to get rid of the 2, square root it, and then, that's right, plus or minus, because this can be positive or negative, and then you subtract 3 over there. Perfect. For f of x is restricted to x needs to be greater or equal to -3. Am I stupid? X needs to be greater or equal to -3. Should be greater or equal than -4. Because that could equal 0, y is equal to negative. Because if x is negative, I couldn't write f of x -1 for y since the inverse is not a function, but if I, oh okay, that's why you can't even write it as f of x. Because it is not a function, but if I restricted the original domain to x is greater or equal to -3, then I would use only one branch of the inverse and I would write in a function. Oh, I see, so he's just taking this branch only, which is gonna be most likely oh, okay, he took just a plus over there. Technically 0. I mean, like, I just don't agree with that statement. This should be greater or equal to -4, right? Because the vertex is over there. Just really fucking throwing me off. Why would that have to be greater or equal to -3? It's f of x. So what happens if it's -4? It's 0. 0 divided by 2 is 0. The square root of 0 is 0. Oh wait, that's an intercept though. Okay, so we want it. Okay, so plus 30. 30 squared is 9. 9. 18. Okay, let's say we wanted to find this vertex. Hmm. I'm not sure if I'm overthinking this or not. I probably am, though. Knowing me, at least. Using a graphing calculator as a strategy to graph a quadratic function and its inverse. Use a graphing calculator to graph f of x equals -2. And this is using a graphing calculator, blah blah blah. It's probably just gonna be plugging shit in. Oh, actual word problem now. Interesting. The rate of change in the surface area of a cell culture can be modeled by the function s of t equals -0.005 times t minus 6 squared plus 0.18, where SST is the rate of change in the surface area in square millimeters per hour in time t in hours, and t needs to be between 0 and 12 or equal to 0 or 12. State the domain and range of S of t. So S of t, we can make that equal 0. So, and it's opening down. So it needs to be greater or less than 0.18. Why does it have to be between 0 and 0.18? Well, I guess, yeah, I guess you can't have negative area, right? So it has to be between 0 and 0.18. The domain is given by in the problem as part of the model. The function is a parabola that opens down. The vertex is 6.18, so the maximum value is 0.18. And the surface area also cannot be Negative, yep. So 0 is the minimum value. That's good. Thomas's solution, okay. So what are we solving here? A, state the domain and range. Wait. No, he solves everything there, what the hell? Fucking Thomas, man, you fucking madman. Label your questions and help us out. Determine the model that describes time in terms of surface area. Determine the model. What do they mean by that? Determine the model. Oh, it's the function that describes time. Time to surface area. I mean, isn't what we have technically doing that? Time in terms of surface area. Oh, so we want to find out what time. We have the surface area. We want to find out what time it's at. The function is a parabola. Alright, Anya, chill out for a little bit. Oh, too much thinking. To find the inverse, okay. So we have S equals 0.005, negative 0.005, t minus x squared plus 0.18. To find the inverse of the original function, I solved the given equation for t by using the inverse operations. You know, I had an idea just now. Maybe I should write down what lesson we're reviewing on the header on the stream, so in case people come in, they aren't asking themselves, what the fuck is going on? Updating this thing every time we move on to a new one might be a pain in the ass. Wait up, let's see if I can quickly set that up. Benefits of being a nobody. You can learn while almost no one watches, if not no one. And I talk to myself. Text lesson. Let's scroll up. What is this lesson called? Oof. Did a lot more than I thought. Can I copy that? Son of a bitch. Okay. Current subject maybe instead of lesson? Subject. The inverse of a quadratic function. Arial font is fine, and text transform, interesting. Vertical. I ain't too smart. Oh, how do I change the color though? This can't be white. It cannot. Is there no way to change the color? Or the size? Or am I just that stupid? Oh my gosh. Oh, stop it. Stop it. Okay. Come on, Damien. You can do it. You can do it. You can do it. These fucking titles. This title had to be so fucking long, too. Okay, that looks good. Now, our only problem is the color is not very good. Change fonts, font styles, and sizes. I mean, how does that look on the stream? Does it look bad? Yeah, it kinda does. What am I doing? I'm just reviewing some grade 11 mathematics. I've noticed I've been pretty freaking, I'm gonna say bad, but I just haven't been that sharp as of lately in mathematics. So just trying to review from the ground up. I felt like grade 11 was a good area to start. Cause algebra was pretty fucking straightforward, right? But once you get into functions and stuff, you can do a lot of interesting things there that don't really stick with you if you don't practice them for a long time. L2. Where's that first part in your name? Is that like some kind of Hebrew or something? Can't really tell. Alright, let's go back down. Oh yeah, and the other thing is, why I kind of also wanted to stream this just because I kind of wanted to sort of encourage people to do self-ed as well. Feel like a lot of people are just too dependent on the education system and for school to do all the work for them. When and then, don't blame you, it's kinda that too half with. Not sure what you're trying to say there. Don't blame you. It's kinda that to half with. It's okay though. It looks like English might not be your first language by the looks of it. Ooh, Nell from Bleach though. That's a cool character. It's okay. It's all good. Alright, where were we? To find the inverse of the original function, I solved the given equation for t by using the inverse operations. Alright. So, oh, interesting. So, this one, or earlier, they first swapped the variables, then solved for the other side. This guy is solving for the other side first, and then he's probably going to swap the variables. So he's moving the point 18, and he's probably going to divide, square root, subtract, yep, solve for t. Oh, no, wait, so to find the inverse of the original, I solved the given equation for t by using the inverse operations. I did not enter. Oh, okay. See, this is what threw me off. He didn't change the S and the T after he did that. I did not interchange S and T in this case because S always means surface area and T always means time. Oh, okay. I was wondering about that. I was actually wondering about that because it felt like we didn't always have to swap the variables technically, but looks like they were only doing it just for the sake of swapping it, just to make it more inverse-like, and just to always keep X and Y on their respective places. But over here, S and T actually have a meaning, so we don't do that. Very good, very good. And the domain and the range of the new model is, of course, just the original, but backwards. And there you have it. And so then over here, whenever we know the surface area, we plug it into here, and then we get the time that it's relative to. Okay, very simple and straightforward, good stuff. The inverse of the original function undoes what the original function has done. Nice wording. It can be used to determine which values of the original dependent variable produce, given the, oh my gosh, okay. Just reading that is putting me to sleep. It can be used to determine the values original dependent variable produce. Okay, so again, it's just another way to, if you want to figure out the end value, the values used to determine the end value is pretty much what it's saying. So it's just working backwards. The inverse of a quadratic function defined over all the real numbers is not a function. That's right, except for it's a reflection, and then the graphs go sideways like that. Oh, interesting. Oh, so when it opens down, it opens to the left. Interesting. Huh. That's cool. It's pretty neat how it's positive opens up. When it's negative, opens down. Negative inverse opens left. Positive inverse opens right. So you can pretty much hit every single angle using a quadratic, essentially. I need to know. The equation of an inverse of a quadratic function can be found by interchanging x and y in the vertex form and solving for y. Interesting. I wonder if that only works in vertex form. Or inverse of a function is its reflection about the line y equals x. Is it always y equals x? Or like, what if I do like a, yeah, it would be, yeah. So it's a reflection, not a rotation, right? In the equation of an inverse of a quadratic function, right? Interesting. So what's the difference between a reflection and a rotation in this case? Like, is there something I'm missing? Like, is it just something completely different? So I remember talking about this back when I was in high school, but it's very foggy in my memory. The question is positive square root function, while negative represents the lower. The inverse of a quadratic function can be a function if the domain of the original function is restricted. The inverse of a quadratic function is restricted. Okay, yeah. Check your understanding. Each of the order pairs defines a parabola. Graph the relation and its inverse. And the inverse, we just pretty much be swapping this. I'm not gonna do it. Like that's just way too easy. We're just swapping the values. Given the graph of f of x, graph the inverse relation. All right, so that's just simple. We just do the since it's I just noticed something. Since it's a reflection on x equals y goes this way. This negatives always open up to the left because it reflects like that. I'm not sure if you can see my mouse movements, but yep. Given f of x, 2x squared minus 1, determine the equation of the inverse. Again, just solve one side, solve variables, super easy function, right? Wonder if they'll give us some more interesting questions like that virus or bacteria question up there. Given this function, x is that. Alright, so we pretty much have to do two things here. Find the inverse and then just, excuse me, plug in the values and, oh, that's an interesting one, but yeah, you'll probably just end up getting a little funny looking answer because of the A. So far, this is looking pretty straightforward. Questions. Sketch that function, sketch inverse, again, same as earlier before. Graph negative root x. For x is greater than 0. Let's see what happens when we graph that. Shit, how do we do a square root symbol on the keyboard? Can we? Let's see if I can find a square root symbol quickly. And just copy and paste it into there. Those are integers. Radical. Yeah, that's the proper way to call it. Let's see if this works. Be pretty oh, it did. Wait. Look at that. Interesting. And then there is the inverse. Well, inverse of half of the inverse of the quadratic, bottom half. So wait, what happens if this is positive? Ooh. Nice. Okay, keep going. Determine the equation for f of -1x. Graph the function and its inverse. Oh wait, we were still looking at this one. 6a. For x is greater or equal to 0, graph its inverse on the same axis. Huh. Technically, the inverse of this would just be -x squared, right? At least I think it would be. So technically, all we're doing is y equals that. Solve for y, which would be multiply both sides by -1, so you get -y equals root x. So we square both sides and then we swap it. Yes. So this is definitely alright. Does that make sense? Math. I hate math. I don't know why I showed up. HTTPS Ava. I don't know. Maybe to learn how SSL works on a deeper level. I'm not sure that's why you have HTTPS in your name, but could be. Wait. Sorry, Nell, what's incorrect? Yeah, okay, yeah. yeah. I don't know what I'm doing wrong right now. Okay, let's see if we can quickly draw this. Draw. Let's see here. Maybe I just need to write it out. Two device, sure. I don't think I can draw on this. Actually, let's do some good old paint. So wait, we have y equals negative root x, correct? Why are you so quiet? I don't know. To be honest, I think it's just because of my mic shit. All my friends always complain on Discord too that I'm always so quiet. I could try yelling. Scream at you guys. Okay. Alright, now. Oh, sorry. I'm on restream.io. So I am talking to someone from Mixer as well. Alright, let's do this. So we're going to do negative y equals the root of x. Negative y. I shall be. Thanks, Ava. I needed the support. Support the maths. Negative y squared equals x. So now you're saying this is wrong. What am I missing here? Unless, what if we... Whoa, did my stream just drop there? That was weird. Okay. Think. What am I doing? Okay, what if we just swap it first? No, that's just the same thing. Alright. let's see if we can Google this and see why I'm having such a hard time with this. Inverse of root x. Wait, let me look at the original equation. G of x is equal x needs to be greater than 0. What's the square root of -2? Ah, you bastard. Okay, wait. Because this is technically what? Okay, if the square root of -2. Okay. I know what you're trying to say. I just need to think about it. Ah. Okay, so the square root. Don't yell at me. Okay, no, wait. I'm just rushing this for no reason right now. I never said root. Oh, what's the square? Okay, yeah. Sorry, I'm just saying root for no reason. You're right. You didn't say root. What's the square of -2? Don't worry, Ava. We all fail something. I was terrible at English. Terrible at English. Ends my native. Alright. Okay, since when you square a negative number. Oh, okay, I see what you're saying. Okay, so you're saying since this is a square, technically this is always going to be positive? No, I don't think that's right. Failing's all part of the journey. I'm failing right now. Oh, that's right? Really? That's why. Oh, that's right. Okay, so let's take this literally, like literally just square y right now. All right. Jeez. Thank you, Nell. That's right, because then when we do this again, and we actually do the inverse of this, we're actually gonna get y is equal to positive negative root x. Yeah, you're okay. You're absolutely right. Very good, man. Thank you. Thank you very much. Graph its inverse on the same axis. It is still half of the solution. Are you saying it's half of the solution because of we're only looking at this line over here, right? Mm-hmm. So in inverse, the x will be restricted to x is greater or equal to 0. X will be restricted to, so in the inverse, this one, x would be restricted to wouldn't it be less than 0? Because the graph is... Oh wait, but... Of course, I'm still looking at the old one. Right, yeah, you're right, you're right. Yes, x would be restricted to greater or equal to 0, correct. So we graphed its inverse. State the domain and range of the inverse. So, okay, yeah, we just did that. So x has to be greater than 0 and equal to any real number. F of -1x. F of inverse. X to the power 2, x needs to be greater or equal to 0. Yep. Because technically we are only looking on this line, and since that's a reflection, we're only looking at this part over here. I see what you're saying. What is left? Oh, right. Whoops. Jeez, man, you're making me feel dumb. Stop that. Stop it. State the domain and range, determine the equation, and we technically did that. Alright. Given f of x is equal to negative x plus 1 squared minus 3, x is greater or equal to -1. Determine the equation for f of -1x. Graph the function on its inverse. So we have this equation. X is greater or equal to -1. Determine the equation for f of -1x. Determine the equation for, so again, solve for y and swap the variables, and then we graph it on the same axis. That is pretty straightforward, but I am pretty dumb. So maybe I should do it. No, I actually think that one is actually pretty straightforward. Given f of x, 0.5 x minus 5 squared plus 3. Find the equation for f of the inverse. For the part of the function where x is greater or equal to 5, use a graphing calculator to graph the inverse of x. Using graphing calculator. Yeah, so let's do it just for fun. So the original one is gonna be 0.5. Oh wait, I lost the question. Oh, it's number 8. Then we have x minus 5 to the power of 2 plus 3. We get this big guy over here. Well, let me see if I can. There we go. It's a nice looking guy there. So inverse is gonna look something like this. It's 0.5, so it's gonna be x minus 3 divided by 0.5 which is pretty much saying multiply by 2, right? 2. Why is this x so big? 2x minus 3. Again, we're gonna need the square root symbol here. Shit. We want all of that in here. And then it's gonna be plus 5. Maybe, would it be better if we put the 5 over here? Plus 5? Yeah, I think that looks more right. Let me take a look at chat. Okay. Okay. So this is the reflection line here. So this is just the inverse on this side. Because this vertex is what? 5 and 3, and this should be 3 and 5. Perfect. Yep, so we did number 8 over here just now, graphing this function and its inverse. And this give us where x is greater or equal to 5. Okay, yeah, that looks right. Ooh. Good stuff, eh? Jeez, 3 people watching. That's intense. 3 full people. I will be right back. I'm just gonna get some water. You're confusing the sides. The upper half of sideways parabola corresponds to the right half of upper right one, and vice versa. I am. The upper half corresponds to the right half. Really? It's when... Yeah, so this one corresponds with this one, because it's a reflection. When you reflect it, it's hard to describe it, but yeah, it has to be this piece over here. Is this leg over here. Let me know if that's wrong, because I thought that's what I said. I might have accidentally said it wrong, though. Yeah. Yeah, I think I just must have said it wrong. Thanks again, Nell. Very helpful, eh? You have a background in math or something? You're pretty good at this. Okay. So we did this one, so let's go to number 9. So -2, oh, so x needs to be between -2 and 3 when f of x is equal to 3x squared minus 6x. Determine. Interesting, so this isn't vertex form anymore. The domain and range of f of x. So we got, well, our x is already there for us, and I guess our y would be not when x is equal to 0. Like pre-college stuff. Yeah, it is. This is grade 11 stuff, and no, I'm surprised. Shocking that you still like retain all this information so well, since you have a computer science background. Like, I don't think this stuff is used too often in computer science, is it? It's not. You're a genius. That's what it is. I got you all figured out. So 9. So let's go do this one. 3x squared minus 6x. Yeah, so y just needs to be greater or equal to -3. I'm trying to remember, is there an easier way to find the vertex? Oh yeah, right, because we have in the, fuck, I don't remember what it's called, that x-intercept form. So all we need to do technically is factor this and then figure out the two x's, add them together, divide by 2. That's our y value for the coordinate. What are you using to plot the graphs? It's called desmos.com. I'll link it in the chat. But yeah, I just quickly looked up like some graphing software quickly on Google. First link. It's very cool. Whoops. Did not mean to show that. Whatever. I got nothing to hide. I hope. Where'd it go? Alright. Wait, did we finish this? Found that. Okay, so then, yeah, so all we have to do is swap those definitions. So this just becomes a definition for y, and then x is equal to anything. X is this. I mean, y has to be greater or equal to -3, so x is going to have to be greater or equal to -3. And this one is also giving us a limit for x. X needs to be between -2. So over here it says x needs to be between -2 and -3. So -2. It goes up pretty high. Don't it? Don't it? Whatever. I need to bring up the chat again. Okay. The height of a ball thrown from a balcony can be modeled by the function blah blah blah, where h of t is the height above the ground in meters at a time t seconds thrown. So write h of t in vertex form. Do I remember how to do this? Let me think. So this is in standard right now. Standard. Huh. Standard to quadratic form. Let's put in quadratic into standard. Oh, whoops, I put, what was the question? Right in vertex form. That's right, I want to go standard to vertex. That's why I'm not finding anything. Oh, that's right, we need to solve for all, okay, right. So vertex form, okay, that's right. All we're technically doing is, oh my gosh, jeez, can't believe I forgot how to do that. Completing the square would be one way. Really. So we have t, so completing the square would be, what two numbers? Give us 5 and 7. Oh my gosh, I'm so dumb. Okay. Square. Interesting spelling. Is this, can we complete the square on this one? It doesn't look like we can. The height of a ball is thrown 5t squared plus 10t plus 35. Alright, this is a quick 3-minute video. Maybe we can learn something. Why not just write it out for me? Alright, let's see what you got here. There could be mistakes. Alright. It's okay, we can take a look at it. We can take a look at this together. Okay, so you 5 T2 and let's grab the original. Okay, we got the original right up there so we can see it. So you wrote -5. Oh, you factored out the 5. Of course. Okay, so first you factored out the 5. The -5 to be specific. Okay, so yeah, so that looks good. So -5 divided by -5t squared. Other way around. -5t squared divided by -5 is just t squared. Positive 10t divided by -5 is just -2t divided by -35 divided by -5 is just -7. And then over here, interesting, you actually subtract 8 out of that equation just to get t2 t squared minus 2t plus 1. Then complete the square for that one. Interesting. Complete the square for that, and then minus 80 there. Now, should that become a positive 40 though? That's the only thing that's throwing me off here, is that positive 40. I'm not too confident about that one. But I guess technically we could just graph it out and see what we get, right? And technically this should be the exact same thing. Power of 2 plus 10x plus, actually 40 makes sense because this is like a 35. So, you bastard, you got it. Look at you go, eh? So the factored form is -5 t minus 1 power of 2 plus 40. It probably is overlapping. What is this? Why is that like that? Oh, looks like things because I didn't put an X. Alright. I can write -7 as 1. Yeah. I got that part. I'm just not sure why. Why did we do this? So you added a bracket. Yeah, I'm not sure why this is 40 though. I get that -5 times -8 is 40. Just trying to get the. Okay, I guess you just. Okay, I see what you're doing. Okay, I've just never. Not familiar with doing things like this. It's a very creative approach though. I like it. But yeah, so you distributed that. Hey, that octopus boy. Nothing much, man. Just trying to figure out how to convert this equation over here to vertex form right now, just to do this first part. But yeah, I got one guy, this guy named Nell from Twitch, helping me out, figure stuff out. Pretty cool. So yeah, so you just took this -5, that -8 inside the first set of brackets, but you kept the -5 still. Because I guess technically you still need to distribute it to this original part, which that -5 was all a part of. Okay, I got it. I understand what you're doing. Okay, so that's going to be our vertex form right here. Determine the domain and range of h of t. So x can pretty much be anything, and y needs to be 40 or less than 40. Good stuff. Wait up, I'm just gonna quickly check my messages on the phone. People are messaging me. Oh my gosh, my friends are talking about a new Netflix TV show coming out where a bunch of people apparently go to an island where they can win $100,000, but they can't kiss or have sex with each other or they lose the money. Man, this stuff people come up with nowadays, eh? Alright, back to reality. Determine the domain and range. Okay, we did that. Determine the model that describes the time in terms of height. Okay, so this is going to be the inverse. So we want the model that describes time in terms of height. Alright, so let's have some fun and do the inverse of this. You know what, let's see if we can just do it in Notepad instead of this. And so everyone can see it instead of me just kind of picturing it in my head. So this is our function here. Y equals this. Oh my. That does not copy and paste over very well. Let me try this. Piece of, no, does that still. Alright. Anyway, whatever. We can just look at this one then. I don't know why I didn't just do this one in the first place. Okay. So we're gonna do y minus 40, and then we are gonna do that divided by -5 square root it square root. Man, so like, can we do a square root symbol in Notepad? Wait, I had a square root symbol here. Where was it? Come here. I wonder if this will work. Okay. Take it and go. Take it and go. Did I really need that bracket there? No, I didn't. What are you doing? I guess. Okay, what? Oh my god. Okay, that looks better. Okay, so that was the square root, and then we do plus 1. So that's going to be our inverse right here. So take that guy and boom. Boom. And I think this needs to be X for it to work. And that looks right. Right, this vertex is gonna be what? We're expecting this vertex to be 40 and 1. So this should be 1 and 40. Well, yeah, there's the 1. 1. Can I zoom out? Man, I can't see the numbers very well. Anyways, looks good. Let's get Nell's seal of approval. You didn't type that time, eh? Okay, so that's going to be our equation to model the time in terms of the height, because that is the inverse. What are the domain and the range of the new model? Okay, whatever, that's pretty obvious. The height of the golf ball after Lori Kane hits is shown on the table. The height of a golf ball after Lori Kane hits, it is shown in the table. Okay. Use the first and second to extend the table. Is this supposed to be exponential? Plus 12.375, 12.37. That's plus 8, 3. The height, and oh, okay, and then it's gonna start dropping. Interesting. Use the first and wait up, I need to take off my sweater. Do you not need to add the plus and negative in this case? Plus and negative in this case, are you... You're talking about this? The inverse? This is a reflection. The height of a ball thrown from the balcony. So, oh, I see. Oh, you're talking about in terms of the domain and range. Is that what you mean? Because technically, time can't be negative, right? 10C. Determine the model describes. So this says, determine the model describes time in terms height. When you square root both sided, how do you decide to take the positive half of the parabola? When you square root both sides, how do you decide to take the positive half? This time has to be positive, right? It's just no other way. But I see what you mean though, yeah. Because, yeah, if technically this is a function, but yeah, it could very well be this if we don't specify. I'm pretty sure it has to be the positive side, right? Because when we're looking at the height of the ball in terms of distance, we're technically looking at this. We were essentially, it's thrown off a balcony, so the balcony like technically starts right here at this y-intercept point, throws it up, and he goes down. So when we do the reflection, it has to be going this way. That's how I'm thinking about it. YH of t. Use the first and second differences to extend the table. The height of a golf ball. This one is kind of throwing me off because we only have the increasing values. So can we determine if the ball is ever going to fall? So we see. So 0, okay, first difference is going to be 12.375. Let's go calculator here. I'm thinking the inverse of t is equal to 1 plus minus so, oh, like you wanna, but if we do plus and minus, it's not gonna be a function, right? And this, well, it's just asking us for a model, but it has to be the positive side, right? Because we're looking at an actual ball travel. right? And the actual line that models the ball traveling is going to be this part of the parabola here, because x needs to be greater than 0, because it just doesn't make sense to have negative time. And also y needs to be greater than 0, greater or equal to 0. But yeah. And then when we do the reflection of this, it's the positive side of the inverse. The ball will be at the same height twice, though. You bastard. You're right. You're so right. Oh. So the model... Jesus Christ, man. How are you fucking... You're so smart. Yeah, you're absolutely right. The ball is at the height at the same time. The ball is at the same height twice, right? The model is not a function, and it is plus minus. You're absolutely right. 100%, yep. Yeah, so technically it should be plus minus. I'm not sure how to do that in this tool though, but I'm not sure. Does that technically do it? Do 1 plus minus. Whatever. I'm not gonna spend time on it, but yeah, you got me. Just add the two equations. Are you using latex? Not sure. What is latex? I saw symbols. I don't think they were. So if I copy and paste, let's see. I'm just gonna bring it back to the way it was, just so copy and paste over properly. We just don't need that. So if I copy and paste that, I go to Notepad. That time it didn't do it. Let's test it on this one. Is this what you had in mind? Oh, no, I'm not using a program to render math equations. This is just this website that I linked earlier plus Notepad. Yeah. Hooga shaka, hooga, hooga shaka. Music stopped. Alright, first and second differences. Let's go. $22. Right, where's our calculator? So we want to do 2.5. 12.375, 10.125, 10.125. That's not 10. Clear. 30.375 minus 22.5. That doesn't look right. Oh wait, yeah, it does. Whoops. 7.875. 7.875. And then that's gonna be mental maths. Let's go. 5.625. And then the next one is just gonna be 3.375. 3.375. All right, and our second difference is it's gonna be, oh, I lost my train of thought there. So we're doing 12.375 minus 10.125. 2.25, 2.25. So that's that. Then we want to do 10.125 minus 7.75. Yep, so that's going to be 2.25. Okay. Use first and second differences to extend the table. Dun, 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 dun. Oh, wait up. I want to check on something quickly. Oh, what am I doing? Need to check something quickly. Want to click on that. Get back, you don't know me like that. Control F. Yeah. Alright, anyways. Back to where we were. So we have all of this stuff here. Use first and second differences to extend the table. Okay. We extend the table like that. So what? Yeah, so that and that is 2.25, that and that is 2.25, that and that. Again, it's gonna be 2.25. 2.25. Two point five, 2.2222. Okay. 1, 2, 3, 4. Extend the table using these differences. Okay. So we can see these differences are diminishing. So it's just plus 2.25, plus 2.45, plus 2.25. So it's minus, minus, minus. So again, we gotta do what? Minus 2.25 on this difference. Ooh, where's my calculator? Give me back my calc. So we gotta do what? 3.375 minus 2.25, which equals 1.125. So, okay, we got this 3.375 because we did that minus that. So we need to do what? This through... Why do I... Oh, no, never mind. I thought I'd keep closing my calculator, but it was just hiding there. We want to do 39.375 plus 1.125. So the next value in this table, we got a good old handy snippet tool. We can go over to paint. Is there a quick way to delete all this? Cool. Alright, and then we post that. So, and this is every half. So, where's my pen? Number 3 is gonna be 40.5. 40.5. Oh gosh, I need to figure out an easier way to write down. Welcome back, Nell. Good to have you back. Use the first and second differences to extend the table. Buddy, that's gonna take so long. The rate I move. Alright, let's just do two more. 1.125. Alright, I'm just gonna shock on this. 1.125. 0.125 minus 2.25 equals. Alright, so here's our turning point. Negative 1.12125. You can literally print 100 rows. You can print 100 rows in no time? Are you talking about if I just plot the points inside a tool or something? Is that what you mean? Oh, if I use Excel. That is true. I'm a cheap bastard though, and I don't have Excel, and I use something called LibreOffice. I'm not very good with spreadsheets though. I always tried avoiding them. I should probably take some time maybe to learn how to use them one day. But yeah, the negative 1.225, and then oh yeah, and then it's just gonna flip, right? So then we're gonna get negative 3.375, and then so on. So go back to paint. This was just that plus that. So then we're gonna 3.5. You know, I'm not familiar with formulas in LibreOffice. Yeah, neither am I. I mean, yeah, who knows if they're, yeah, I'm too unfamiliar to even have an opinion on it. I'd imagine they'd be similar. Probably don't want to reinvent the wheel if you don't have to. 39.375 and then 375 and then number 4. It's just gonna be this number, right? 36.0, and then we're just gonna be working our way down. That's our parabola for this. Graph the data and curve of a good fit for the relationship. Graph the inverse. Okay, so, well, I mean, like, okay, so, okay, that's pretty straightforward though. Okay, so since we figured out this graph, we have the parabola. We can see that it is starts at 0, and then a 0.5 ends opening up this way. And then all we do is reflection, and then the inverse is going to be opening up that way. Is the inverse a function? Oh, wait, no, I'm an idiot. I am completely wrong, actually. This is wrong. How do I crop this out? Or can I just undo? Because even it doesn't start at 0, right? Because we figured out that the vertex is over here, or somewhere around here. It's probably this. I'm too lazy to actually just do this the proper way, but I get the idea, so I'm confident I don't have to go through the whole process, but it goes through 0, but it actually, oh my gosh, it goes like that, which means the inverse is not a function. It's just gonna be going, well, it's not even gonna look like that, right? It's gonna be like some shit like that. Is there a function? No, because this wasn't a function. Oh, since we are actually have some context to this equation, and we are finding, so right now we have time relative height, so we are graphing height relative to time. So height is always going to be greater than 0. Height is always going to be greater than 0. What does that mean? Height is always going to be greater than 0. So before, time was here, height was here, but now height is here, so it opens up this way and always has to be greater than 0. Oh, okay, so this inverse actually needs to intercept 0 at one point, and yes, it is a function because we are actually graphing the height of the ball, which actually has a domain and range that forces it to be a function. So I would say yes, it does have to be a function. The inverse is a function technically. Okay, consider negative 2x squared plus 3x minus 1. Determine the vertex of the parabola. Okay, whatever. We pretty much just factor this, solve for the two values of x, divide by 2, graph of x, whatever. Determine domain and range. Each graph shows a function of f that is a parabola or a branch of a parabola. Determine f of x. Inverse, state restrictions, okay, same stuff, okay. It's getting repetitive. Yes, this is called practice. Oh, the extending questions are always killer though, but usually probably the ones that actually force you to actually think about this stuff harder than you normally would. What must happen for inverse of a quadratic function defined over all of the real numbers also to be a function? What must happen for the inverse of a quadratic function defined over all of the real numbers? I'm reading this, but I'm not thinking about it. What must happen to the inverse of a quadratic function defined over all of the real numbers also to be a function? I think there's a few ways to word this one, right? Because I don't want to just redefine what a function is. What must happen to the inverse of the quadratic function? Well, you can only take the positive square root value or only the negative square root value of the inverse of the quadratic. And I think that's probably the best way to say it. If you were given a quadratic function in standard form, explain how you could determine the equation. If you were given it in standard form, explain how you could. So let's say you get x squared plus x plus 1. Well, you could always put it into vertex form and then solve. Well, what if we want to keep it in standard form? Is there a way to do it to keep it in standard form? I mean, like, yeah, I guess technically you just first swap the values and then solve for the other side. Yeah, you can do it in standard form just fine, probably. You know what? We can test that theory. So let's pretend we have something really basic like x squared plus x plus 1, right? And this is what y equals. And then to find the inverse, we could just do x equals y power of 2 plus x plus 1, which would equal x minus 1 minus x over the square root, pretty much. So I'm just gonna put that in the graph and see if that is right. So we took this. Oh, true. This should be. Oh no. Y. That's what I meant. We wanted to swap the x's and the y's here. And then square root symbol. Come to pop up. And then we want to say square root of x Wait, I just noticed something. Oh, okay, wait. We're solving for x. Ooh, I just noticed something. Because I'm saying x. First of all, x is on this side, so we want to bring, okay, first let's bring over that -1. Next, we have equals y to the power of 2 plus 1. I mean, plus y, because we move that. Okay. So this is what we're left with on the right-hand side. I mean, you know, it would have been easier if we just made this like something random like 3x. Made this 3y. Maybe that's easier to think about it. I guess you can't just swap it like that, because you can't really solve for the other side very easily. Alright, I guess I'll just leave it at you have to complete the square again. Yeah, that's what I was thinking. Like, you just have to factor it again. I was trying to see if we could keep it in standard form though, and still calculate the inverse, but it doesn't look like you can do that very easily. If the domain of the quadratic is x equals any real number, will its inverse be a function? No, because then it will fail the vertical line test. Or if you know the quadratic formula. I do know the quadratic formula, but for some reason this textbook still hasn't covered the quadratic formula to this point. So, I mean, like, but yeah, you're right. You could just plug it into the quadratic formula, convert But yeah, but the putting in the quadratic formula is just converting it into vertex form technically, right? It's operations with radicals. Dude, that's so rad. All right, probably just finish these last two questions and call it a day. Probably take this one up probably later time, sometime this week. Maybe we could do a lesson a day. That would be pretty ideal. Maybe once I sharpen my math skills, we can move through this faster. A meat department manager discovers that she can sell mx kilograms of ground beef in a week, where m of x is equal to 14,700 minus 3040x. So she sells it at x dollars per kilogram. She pays her supplier for the beef. Wait, a meat department manager, so she can sell in a week. So wait, discovers that she can sell m of x, y. Okay, so m of x is kilograms of ground beef in a week, where the kilograms, or mass, is equal to 14,700 minus 3040x. What's x in this case? I guess that would be the units sold. She sells it x dollars per kilogram. Wait, x is dollars now? What? She pays her suppliers $3 per kilogram for the beef. Determine the algebraic expression. Determine an algebraic expression where P where I'm guessing is price. Alright, so what are we doing here? So we know that mass is equal to 14,700 minus 3040x. She pays her supplier for price is equal to what? 14,700 3040x. She sells at x dollars per kilogram. She pays her suppliers $3.21 per kilogram. So let's do 3.21 times this, right? Determine algebraic expression for P of X, where P of X represents the total profit in dollars for 1 week. I wonder if there's an answer key to this one that I can just follow along with. So I'm just going to open up a second instance. might not do that. Interesting. We can go open with edge. Just scroll down to nice 162. Would have been nice if I remembered this one earlier. Alright, we're on question number 16. That's 17. A. What? That is completely... Okay, I'm misreading the question here. I got this part. They're saying that I need to do x minus 3.21. Now that's throwing me off. X dollars per she pays her supplier. Like I'm misunderstanding what X is here. I thought X would be units moved. So that she can sell M of X. So Y kilograms of ground beef in a week. So this equation represents how much she can sell in 1 week. She can, if she sells it at X dollars per kilogram, alright, so now X represents money. I'm not getting this at all. What? Okay, I need to think about this one. Okay. She can sell... Okay, so we know this is how much she is selling in 1 week. She sells it at X dollars per kilogram. She pays her suppliers 321 kilograms for the beef. And question number 16 says P of X equals... This part makes sense. I'm gonna zoom in quickly. This makes sense. Why are we doing money minus money made per kilogram? Total profit for 1 week. So this is how many kilograms she sells. Oh, okay, and this is how much she's paying her suppliers. So this is how much money she's losing per kilogram. Okay. Okay, this still doesn't make sense to me. How? Okay, she pays her suppliers $3.21 per kilogram for the beef. So X is units here. So shouldn't this be 321X? Why are we doing it X minus? Like they're saying over here, they're saying that if X is units, we sell 1. So let's say we sell 5. Okay, that's gonna be a positive number. We sell 5 of those. That's gonna be 5 units there. And that's gonna be our profit. God, you're right. Man, like these simple things. That's right. Profit is equal to revenue minus cost. So you're saying that sell price minus cost price. Oh, okay. If she sells it. Oh, and X. If she sells it at X dollars per kilogram. That's interesting because I thought this was mass. Given that she sells at X, the quantity is MX. So profit is equal to. But what's X in this case? X is. Well, like I don't understand. Why are we doing X minus 3.21? So this is her revenue over here. This is selling price. Oh, okay, and this is mass per kilo. Okay, right, okay. I had it there for a second. 14,700 minus this, which is the price that she sells it at for dollars per kilogram. She pays her supplier. X is selling. MX is quantity of meat. Oh, okay. I get why. Okay, so why we're actually doing. Okay. Okay, I see what we're doing here. Okay. We're doing. Okay, it's okay. We're doing selling price minus this price because this is her price minus the meat provider's price. Okay, gotcha. Okay, so okay, I was thinking. Okay, I was approaching it from a different angle. Okay, I see that though. And then we do that. So this is like technically the real price times the amount of kilograms sold. Okay, that's cool. Okay, got it. Thank you again. Appreciate it. interpret its meaning. So we're gonna do y is equal to we're gonna have 700x space out there. That, and then this is gonna be minus 3040x squared plus 14. Whoops, no, we already did that one. That, and then we are gonna need a calculator for this one. 3.21 times 14,700. It's gonna be minus 47,187. 47,187. And then again, 30, 40, 30, 40. Times 3.21, which equals a very weird number. Plus that. And then, which means then we need to add 47,187. Oh, never, nope. We do 47,187. Negative? Nope. Oh my gosh. Excuse me. Where's the positive negative symbol? Oh, there it is. Negative that plus 9797.775, which equals this. Oh wait, I'm doing this wrong. You should have gone, yeah, I just noticed that. Yeah, this one was supposed to be an X, and we're actually adding these two up together. So we get y equals 3040x squared. And this is where we add up the x terms, which is going to be 14,700 plus the 9797.775, which goes to 24,497, 24,997. 7x minus this guy. You could leave it factorized. What was the original question anyways? Find the equation for the inverse. Interpret its meaning. We could have left it factorized. So you're saying we could find the inverse while it's factorized? What am I missing here? Did I not put a negative in the calculator? Oh wait, meant that one, right. Find the equation for this. So we have this. So, are you saying we shouldn't even like solve it? Just literally just swap x and y and not even bother with finding the inverse? Let's see what they think. I mean, like technically, it's like just leave it. Like it all means the same thing, right? So in the answer key, they actually looks like they actually went ahead and solved it. But yeah, technically this is right? I mean that's all an inverse is. And what does it mean? It just shows us how much she needs to, what she should price her meat at in order to make a certain amount of profit. I'm a tack and wing. Not familiar with mixer. What does that lightning bolt there mean? That's a cool looking thing. Rip. Find the equation for the inverse relation. Write an expression. I'm a tick and wing. Okay, I'm sorry. Tick and wing. You're tick and wing. Tick and wing. Mr. Tick and Wing. I'm more of a chicken guy. I'm a chicken wing guy. But I've heard chicken wings are good too. The supply cost drops. Where am I? I'm on C right now. Write an expression in function notation to represent the price that will earn you 1900 in profit. Evaluate and explain. Write the expression. So all we're doing here is doing yeah, this would be a lot easier to work with in Vertex form because we only have one value of x and y. But goddamn factoring this would be a pain in the ass. But we could also just use the quadratic formula. And then we should just be able to, I guess, get this. And then in this one, they just plug it in. And then solve for it. They get two values. She'll make profit at 1900. I guess we'll just leave it at that. I kind of just don't want to work with those ugly ass numbers. Also starting to feel a little fatigued too. Determine the price that will maximize profit. So again, if we had this in vertex form, we just find the vertex. I mean, technically we could, it's actually pretty easy to do it in this, right? Because if all we're doing is finding the vertex, we have our two x's. So pretty much all we're doing is negative 3.21 plus, oh my gosh, it's gotta be another ugly number, because we need to figure out what makes this right side 0. Where's my calculator? This equals 0 when we do 14,700 divided by 3040. Let's go up 4.8. 4.8. Was it 8.3? And it's all of that divided by 2, which equals 1.62. Is that the answer for D? .02. Did I? I thought I did. Did I? Oh, that's right. Divided by 2 should equal 0.81. So that is telling me that this is our the reason that this I must have done some Damn it, you're right. That's where I went wrong. You're right, because it's the positive makes it, will make that actually 0. You're right. So I actually need to do 3.21 plus 4.83 divided by 2, and look at what we got. 402. The supply cost drops to 310. What price should the manager set? How much profit? What price should the manager set? How much profit will be earned at this price? Interesting. So we're pretty much working with this same equation, but this guy, oh wow, he gave her a nice deal. Dropped by 11 cents. This becomes 3.10. So pretty much we're taking this guy here, do 310 plus that, and our calculator, which we can clear here, 3.10 plus 4.83, and divide that by 2, and that is what she should price her meat at in order to maximize profits. 3.97. Yeah, I just didn't round it to 2 decimal places, but yeah. All right, number 17, the last one, the big kahuna. You are given this relationship. Graph the relationship. Determine the domain and range. Determine the equation of the inverse. You are given the relation. Alright. I'm actually not gonna graph it. I'm gonna plug it into here, right? 4.4y plus y squared. Oh, okay. It's technically backwards, but okay, let's do it this way. X squared minus 4x plus 4. X squared minus 4x. That, okay. And this is the graph that we get. Nice looking graph. Determine the domain and range. So x can equal any real number. Range y needs to be greater than 0. Determine the equation of the inverse. So again, okay, whatever. Let's just do it. Blah, blah, blah. We need our trusty square root symbol. So we are gonna do x minus 4 divided by 4. Nope. Divided by 4. Want to take this guy, put it all under here. Am I forgetting to do something? Oh my gosh, what am I? The equation you plotted is the inverse. I mean, like, yeah, technically. I mean, are we taking this literally as in this is the inverse? Is that what that question wants us to do? Because I see what you mean, like, the x is on the left-hand side and we have all the y values there. Okay, so I guess technically C is asking us to find the inverse of the inverse? Because this is technically a parabola, right? Regardless. So, I mean, the other way to think of it, this is a parabola. And it wants us to find the inverse of this parabola. I would assume. Son of a bitch, what? How is this a sideways parabola? Is it just because this is literally the y coordinates? Is that why? Because when I plug in the same values here, except I just put in x, it turns into a parabola. But it actually wants us to treat these y values as actual y coordinates. So then, yeah, that would make sense. Okay. And is the inverse a function? So since this is an inverse just opening to the right, the reflection would be a positive quadratic equation opening up. So yes, the inverse is a function. Graph will pass the vertical line test. Oh, that's cool. Okay, I guess we could try doing C as well. So since this is technically already the inverse, we need to take that equation, and then we are gonna say x is equal to what was it? 4 minus 4y plus y plus y. And then inverse is going to be y equals 4 minus 4y. When you swap, that's when you swap x and y, you are plotting the inverse. Yeah. X plus x. Oh wait, I forgot to put power of 2 up there. Power of 2. And I guess I'm going to rearrange this so it's easier to look at. And then I think we are just, again, solving the square. X plus 4. Which is what? 1, 2, 2. Wait. It's going to be x. -2. Okay, yeah. So then we got -2 or -2 when multiplied together give us 4, and when added together give us -4. So yeah, so what we end up getting is y is equal to x minus 2 squared, which from what I remember is the answer we got here. And yes, it is a parabola. All right, cool. Lesson all done. All right, very cool. Thanks a lot, Nell. You're a huge help. Oh, man. That feels good. Next time I'm going to try doing operations with radicals, which from what I remember is actually pretty damn easy to do, because it's almost like doing algebra with exponents, where they have similar rules where it's like same base, you can add them and stuff like that. Alright, hopefully I can stream this some other time. I don't really have a schedule, but yeah. By the way, no, just out of curiosity, like, why are you just like sticking around and just like helping me out? It sounds like you already know how to do all this. You're welcome. I'm bored. Really. There's nothing more interesting on Twitch. I usually find some pretty interesting streams to watch. You're watching the ESL Grand Finale. Really? Is that for, that's for Counter-Strike, right? ESL, I think, if I remember correctly. Yeah. You're a CSGO player, eh? You excited for Valorant? That's what happens when you come hang out with the little guys. Finding us at the bottom of the category. No problem. You're welcome, man. Least I can do for your time. That's a part of their goal, is to make the game like extremely easy to run so anyone can play the game, if I remember correctly. Let's see here. Valorant PC specs, because I'm sure if you can play CSGO, I'm pretty sure you can run Valorant. Yeah, you can run it on an i3 for fuck's sakes. But you're gonna be playing at 30 FPS on these ones. Boy, on Intel integrated graphics on an i3, you can run on 30 FPS. So I think you'll be good, and I think the game's gonna be free to play. So no risk in even trying out, just in case. Got nothing to lose, is what I'm trying to say, at least. I'm not sure if you've ever played a game made by Riot, specifically League of Legends, but I can tell you, they're really bad at balancing their games. So I feel like the same thing's gonna happen as what's pretty much the state of League, or has always been, where just something's just always so broken and everyone's abusing it, and every few patches they're always changing what's broken, and it's like kind of frustrating. Hopefully they don't go down that route with Valorant though, and just keep it to strictly gun skill, and abilities are just there to do some creative plays. Yeah, League's a hard game to get into. It's since everyone's so good, and all the new players. The game looks good though. Yeah, there's definitely a lot of good things to say about League, but it's really not friendly to new people. Because there's so many experienced players trying to level up like second and third accounts to just fuck around in ranked. So all the new players that are just starting out are actually playing against really good people, and it's really hard to learn. And even when you learn how to play, the game's really hard to master. Like I'm pretty crap at the game, and I've been playing it for 7 years. Yeah, but in CS:GO, I think you can play ranked right away. Like, I don't think you have to level up an account to start playing ranked. Where in League, you have to level up to level 30 before you can start playing ranked. And the entire grind to level 30 is playing against, like, people that already know how to play the game and stuff. They're just absolutely destroying you. I hate that people do that in CS all the time. Yeah, looks like it just happens in every game. Can't get away from it. Always helps when you have a friend or someone that can hold your hand along the way. So, once again, thanks a lot for your help. I'm gonna head out. They buy silver accounts. Jeez, no, that's just weird. They waste money just to play low level people. All right. Anyways, I hope to see you around now. That was really helpful. It's pretty fun talking to you too. All right. Have a good day. Oh, nice. My OBS crashed. Mm. Hello.